my great pleasure to introduce our first keynote speaker of the conference, Professor Marcel Jufer from École Polytechnique Fédérale de Lausanne in Switzerland. Professor Jufer has been involved with the concept that we're talking about, which is mainly high-speed transportation in enclosed environments, for a very long time, leading this project that's he's going to talk more about called Swissmetro. I learned about it just by being involved with this conference, so that's been one of the feats for me, but hopefully it's going to also be for many of you that may not know about this Swissmetro. And without further ado, I want to welcome Dr. Jufer. Thank you.
Good morning. Probably I made a mistake with the title of my conference. I should have called it Back to the Future. Maybe two words to explain first. What is Switzerland? Switzerland is a very large country in the middle of Europe. Population 8 million. The largest length is 200 miles. So very small country. It is not even in the European Union. Second, what is EPFL, or Swiss Federal Institute of Technology, Lausanne? You see it's a nice place. In the background you have the city of Lausanne, in front the Swiss Federal Institute of Technology and the Lake of Geneva. We have in this campus 10,000 students in science and engineering and 3,000 collaborators, professors, and so on. Back to Switzerland, the brown part, it is Alps, almost no population. The green part is Jura, like Jurassic Park, which is almost no population. So you have just a central part, which is called the Swiss Plateau, with all the population, as you can see left under. So all the connections are mainly between east and west. This means if we intend to have a good connections, it must be in this direction. Unfortunately, we have a very good railway network, but it is almost saturated. Impossible to do new lines because the density of population in this part. And second, impossible to go fast, to create a TGV as an example, because the topography, nothing is really flat. So we propose to consider Switzerland like a large city with some important points, which are the real cities, and to consider it like a metro. Swissmetro project started by a proposition. Afterwards, during 10 years, it was a preliminary and a mind study with a relatively important number of people and company. In 1997, it was asked for a concession in Switzerland for a pilot track. And EPF Lausanne, with the help of Zurich, was a leader for the development of the project, but it was also 85 companies participating to this project. So it was a complete study. I will speak of what happened up after. What is Swissmetro? Underground city, metro. The problem is the cost. To be underground on such relatively important distance, finally, is an important cost. So if we use small diameter tunnels, it will be less expensive. It's not proportional to the diameter for the cost, but to the cross section. Aerodynamic, if we are in a tunnel with a relatively high speed, so it's only one solution. That's the solution used by all planes, is to go up, or similarly, to reduce the pressure. We have chosen 7%. Today, we would not choose the same pressure. The reason was the cost and what existed on the market to create vacuum. If we are in the vacuum, we cannot do any maintenance, or it's very complicated to do maintenance in the vacuum. So the solution is to have no wear. So magnetic levitation and guidance was the solution proposed with linear motor. Finally, having a typical distance between the cities, which are in the range of 60 kilometers, the maximum speed, or the optimum speed, was in the range of 120 meters per second. No reason to go at the sound speed for 60 kilometers. City to city time, typical time, 9 minutes, which means the possibility to reduce all the times of transport by a factor 3. So to summarize, Swissmetro Underground, we had from the beginning one problem. The railway network direction was not very favorable. They thought it would be the death of the on-ground transportation, but it was a mistake from them, because today they cannot improve the quality of their network. Just to have an idea of the size, 5 meters for the tunnel, and the body of the vehicle is 3.2 meters, which correspond to a Boeing 737. In blue, the linear motors, in green, the guiding system, and in red, the levitation system. Just to be clear, this proposition has to be considered as a wingless plane and not like a train without wheels. The difference is important because when you build railway material, you need normally to have something strong because many shocks of the wheels on rails at the connections. In this case, we are building or proposing a solution like a plane. Typical vehicle structure we studied is the typical structure of a plane. We made many studies. As an example, aerodynamic, with here the possibility to determine at different sections the distribution of speed of air around the body of the vehicle, 3D, including the time effect, having all world effect and all problems behind the vehicle, also all thermal effect here for a levitation device. We build many components, some at full scale, some at reduced scale. Here it's typical two types of linear motors. One is induction motor on the right, and the other one is a homopolar synchronous motor with the advantage to have no PCs, which has heating on the vehicle. What happened with a project, something like this? In '97, we asked for a concession to have the possibility to build a pilot track. But we had never an answer from the government. They said, oh, why not? But we have a priority, that's the basis tunnel of the Saint Gothard, which is a tunnel of 57 kilometers long under the Alps. It is now built, and maybe this project could restart. Swissmetro Hyperloop. What are the differences, and what is specific to Hyperloop? rating distance for 400, 50, 100 kilometers, which is longer. The basic structure is a double tube on pillars. You know this picture probably. As a difference, vacuum 1 per 1,000. Nowadays, it's possible to create it. It's difficult to maintain it with the necessity to go inside vacuum, outside vacuum with the vehicles, and automatically we have leakages. Just to have an idea, where do we find here the pressure we decided for Swissmetro? It's an altitude of 20 kilometers, and for the 1 per 1,000 is 47 kilometers. Levitation and guidance. I am speaking at the moment from Hyperloop Alpha and more or less Hyperloop 1. When I read this air cushion, I was really surprised, more than surprised. We are in a vacuum of 1 per 1,000. Why do we want to create an air cushion? Where to pick up the air? The answer is easy for an engineer. It's not so difficult. First, you have to swallow enough air to create this cushion. How can you do this? You just have to go fast. And it's impossible to have enough air before to reach the speed of 300 to 400 kilometers per hour. So no solution at low speed with air cushion. And for me, it's a nonsense, because to create an air cushion, if you have enough air, you must have the good pressure. So you need a compressor, you need energy just to create this air cushion, which is something which is not the best solution. Nowadays, nobody speaks anymore from air cushion. So you have seen all these pictures probably with here the compressor to create the correct pressure. Propulsion by linear motor, it's a good solution. Induction linear motor is a good solution. You have all seen this picture. It was in 2016 presented as the first realization in the world. Okay, in 1969, we had the pleasure to create our own Trike. It is smaller, but the same acceleration. Speed, you know the speed, which is the goal for Hyperloop, with an acceleration of 1g. I will come back on this point afterwards. Now, just a small summary. What are the differences between the Swissmetro and this Hyperloop project? Underground on pillars, 2 tubes. Diameter smaller for the tubes, for Hyperloop 1. The vehicle is a lot smaller. This diameter is just like if it would be a circle, even if it is not a circle, just to have an idea of the section. Air pressure, very different. I think 1 per 1,000 is the actual best solution. Air cushion against magnetic levitation, I spoke before. Brushless DC linear motor or linear induction motor, both are good solutions. Another big difference, in Swissmetro, we transfer the energy which is necessary in the vehicle contactless by induction. In the Hyperloop 1, it's on batteries. The problem is we have to change very often the batteries. Another aspect, acceleration we have chosen on Swissmetro was the same as in a usual railway. 1g. What is the difference? We have chosen for Swissmetro a relatively important vehicle with 200 or 400 passengers. For the Hyperloop 1, the small vehicle is 20 passengers, 15 tons, with 1/3 just for the batteries and 1 part for the air cushion. maximum power requested for Swissmetro is 6 megawatt and 50 megawatt if we keep 1G until full speed for 28 passengers, which means 50 times more power. Energy is more or less the same, but the power is quite different, and power is the investment. So the investment becomes very important if we keep the acceleration until full speed. That's what is claimed in the different papers presented until now. Just do an explanation. If we have a constant acceleration, we will have a power increasing with the speed. In every railway system, we work with a constant acceleration, and after a given value, here, a given speed, we keep a constant power. In my mind, that should be done now with Hyperloop 2. If not, investment is too important. And the consequence is, naturally it's a consequence, we reduce the acceleration with the speed, and doing this, the time of acceleration is a little higher, but who cares if we lose 2, 3, 4% on the travel time. But this must be changed. It's not only Hyperloop 1, it's also Hyperloop transportation technique, and they are quite different compared to the Hyperloop 1. First, we have permanent magnets for levitation by repulsion, which means we must have also some permanent magnets, not permanent magnets, wheels to start, because this system will work only at relatively high speed. We have linear motors with a converter and batteries. So all the energy must be on the vehicle, which means a relatively important part of the vehicle is batteries. Comparison also, maximum speed, acceleration, which is announced, is the same. The tunnel diameter is higher, is smaller than Swissmetro, but higher than Hyperloop 1. The vehicle diameter is in the same range as the ratio of those are the same. The vehicle length we had was longer. Here it's announced 30 meters. Loaded vehicle mass 24 tons compared to 50 or 100. But this time the power is still higher because the mass is higher. Just to have an idea, a TGV power has maximum 8 megawatts. 80 megawatt is a little crazy for me. It must be reduced. Power per kilo, always the same ratio. Now, there are not only Hyperloop 1, Hyperloop TT, it's also Virgin Hyperloop, more for good transportation. Just to have an idea, these are the permanent magnet devices for levitation by repulsion, with also wheels, just to start. Now, approaching the conclusion, I would speak of one very important aspect, safety elements. What did we study with Swissmetro? Any accident could once happen, you never know. If it is the case, what is important, because we are in vacuum here, is to introduce rapidly air. Like if a plane has a problem at a high altitude, it must be capable to go very fast at an altitude of about 5,000 meters. This is not so easy. It's not just to open a door and let air enter. It could be a big wave which could destroy the vehicle. It's important to inject air at many places along a portion of tunnel in order to introduce air without wave, without shock. First solution, air injection. Another solution we had with our double tunnel, to have a third tunnel with the possibility of connection and to evacuate the people with the third tunnel. Which means a lot of different devices, structures, station, air evacuation or injection, the possibility to have connection between the tunnels, to have a permanent connection between the tunnel, to have the air rotating between this instead to go always in one direction, because every tunnel has vehicles only in one direction. So all these elements have been studied for our project. Now, speaking of safety on Hyperloop, we have tubes. What could happen? Accident is always possible. It's not possible to have a shock in a tunnel, except by the vehicle, from outside. In this case, if you have maintenance vehicle coming here, one could have a shock against the tube. What will happen? Could be an implosion. If it is an earthquake, could be also some serious problem, more than with the tunnel. Another aspect is sabotage. There are always somewhere some people who are crazy. It's relatively, unfortunately, it's relatively easy to make a sabotage in such a case. In a tunnel, as you cannot go in the tunnel, you cannot do a sabotage in the tunnel. What is the solution for evacuation? For Hyperloop TT, they say every 500 meters, or they will have a door to evacuate. It's not very obvious to open the door in such a case. So this has still to be solved, I think. Maybe it's done, but not published. Now, just two things. This I have read, the 20th of February this year. What does it mean? If I read correctly, it means probably Hyperloop goes underground. If we are speaking of tunnel, of the boring company, it's to go underground. So, in my mind, maybe Hyperloop becomes a faster Swissmetro. Conclusion? What does it mean? Two things for me. The first, maybe from air cushion to magnetic levitation, Hyperloop has to evolve, or is evolving, or has maybe already evolved. I am thinking also to the government of Switzerland. Recently they published the future of transportation in Switzerland is our railway system. How can we improve it? No answer. Yes, an answer. Automatically, we will make it automatic. Maybe we can win something. Maybe we will do the railway station longer, so we can have longer trains. But it doesn't solve the capacity of trains. So it's my conclusion, and thank you for your attention.
Thank you very much. Professor Jufer, any questions? We have maybe time for a couple. Yeah, okay.
To learn from history and not repeat the mistakes of history, I think the area of most interest for many of us in the room is what went wrong with Swissmetro. It seems like technical feasibility was there, the technology was in place, but government did not give you the concession. Sounds like it's still an ongoing problem for Hyperloop technology around the world, working with the government, getting that approval, getting financing. So any insights that you have to share in that blocker and that obstacle for the room?
Okay. First, the first reason is an opposition of the railway company, which is not a private company, it is a part of the government. They were opposed, mainly by their director. But that's not the main.
Could you repeat the question?
Okay. What are the reasons for the opposition? The Swiss government not realize the Swissmetro. Opposition of the railway company, but most important, it was, that's a complicated situation. Switzerland is in the middle between Germany, Italy, France. And it was a big problem of transportation between north and south. And all this was done by trucks through the Alps, which is very complicated. There are tunnels for trucks, there are passes, but it was a big opposition of the country. And they decided altogether to facilitate the north-south transportation by a basis tunnel. 57 kilometers. The cost, by chance, is exactly the same as the cost of the first line, east-west for Swissmetro. And they decided priority is north-south. But unfortunately, it doesn't work so well because in Germany and in Italy, they don't build the loading stations.
Next question.
It's a pleasure to have you here. In the Swissmetro model, the switch to get Swissmetro from one track to the other was originally a cylinder system. Is that still the system you would think would be used in Hyperloop?
You are right. Metro, to go from one tunnel to another tunnel at the end of the line or in the middle of the line, it was a kind of revolving system which can turn a vehicle from one tunnel to the other. Another solution was just to rip the vehicle laterally from one tunnel to the other. Both are possible. We had a patent on the first one. Now it's open. But it's really a problem to solve. To do a turn, to go from one to the other is too complicated and too expensive.
So, hopes that we can stay with the schedule, I'll invite you to come back to the copyright or lunch or the reception. And from all this, thank you.